Okay, so what we've got to be able to do is figure out the angles in the pie charts. So, first of all, what does a pie chart show us? What's it for?
The amount of data and what is to organize.
Well, actually it depends. If I just show you a pie chart, just a pie chart, that I've done, what does it actually show you?
It shows you how much of all the data is in each section.
Does it show you how much of each
No.
data?
It shows you roughly which data is more than other.
Yeah. See, that's the thing about pie chart, is it's all about this word proportion. Okay? Because when you do a pie chart, the pie chart does not change size, determine it based on how much data you have. So it's all about a proportion. It's about a fraction of an amount. So what you need to do, a pie chart, what it shows is how much of one thing there is compared to another, rather than how much of one thing there are. Now we can work out how much of something there is, and that's how we create the pie chart in the first place. But if I give you a pie chart, there's one piece of information you have to have written on that pie chart before you can work anything else out, which is, oh well, it should be labelled anyway, but no, that's not what I was thinking actually. A pie chart is useless for doing any calculations without knowing. But you can measure that, so I don't need to tell you that.
Without knowing how many degrees equals 1, whatever it is.
So what would I need to know to be able to figure that one out, though?
How many are there in each thing?
Or, not even in each thing, but in
The whole thing.
the whole
Yeah,
thing. A pie chart, if you're going to do any calculations at all from a pie chart, you have to know what in total the pie chart represents, and then you can figure out what each thing is worth. Okay? So, for instance, let's have a look. It says, the scores obtained by 20 pupils in a maths test are listed in that square. Alright? So, we're going to do a tally chart just quickly. So, how many ones are there?
2.
Oh my god.
So I've got to do 2. Okay. How many 2s are there? 1. Okay. I'm not doing the tallies, am I? It's not really necessary. How many 3s?
3.
1, 2, 3. Okay. How many 4s?
2.
2.
How many 5s are there?
3.
1, 2, 3. How many 6s?
3.
Just like do it while you're writing.
7.
2.
1.
No, 2.
8.
1. 1. 2.
9.
2.
10.
1.
Okay, now here's the thing. So, as I said, a pie chart shows a proportion. It shows a fraction of a whole amount. So basically, there's 2 things we need to know. One thing we always know. A pie chart, the angles are always 360 degrees. We know that. We don't have part of a circle for a pie chart. What we now know is that the total frequency is 20. So we have to fit 20 into 360 equally. Alright? So there's lots of ways that you can do this. Alright? One way is to figure out, well, if there are 20 people in 360 degrees, how many degrees does one person get? How do we work that out?
You do 360 divided by 20.
So 360 degrees divided by 20 people means that each person, okay, gets 18 degrees. That's one way of doing it. Which would mean then that 2 people get 36, 18, 3 people get 54, okay, 36, 54, 54, Yeah, but we've worked it out. Alright? Now, that's the way we've done it by working out one person. But they've done it here in a slightly different way. Okay? So that's what we're going to look at. So, what have they done? Well, they've worked out that it's a fraction. Okay? So we have 2 out of 20 of 360 degrees. We've got to have the same fraction. So that's what we do. So 2/20 out of 360. Another way to look at it is 2 out of 20 is the same thing as what out of 360 degrees. Right? So we can use equivalent fractions in that way. Okay? However you want to do it, that's up to you. How would you work out 2 out of 20 times 360 degrees? Tristan?
You can do 20 divided by 2, would you?
No.
Or how? Well, 2 out 2 is the same as 36 and 360. 2 out of 20
Is what? Sorry, it's the same as what?
is the same as 36 and 360. Is it?
Yeah? Okay. There's one way of doing it. But how would I, so we've done that, but how would I do 2/20 Archie of 360?
So 20 times 18 makes 360. So 2 times.
But that's this way again, isn't it? So times 18 times 18. I think it's easy. 2 out of 20 is, well, times 10 fractions. But I'm actually asking for you, if I were to give you 2 over 20 times 360 degrees, what do you do?
You could either simplify the fraction, or you could just do 2 times 360 divided by 20.
2 times 360 divided by 20, yeah, or 360 divided by 20 times 2, which is what we did to start with. Or I think you said simplify to 1 out of 10 times 360, which is the same thing as doing 360 divided by 10, which is 36. Okay? But it's all about maintaining that proportion. Alright? It's about maintaining the fraction. Yes, Sush?
We could also cross out the zeros from 360 and 20 and make it 2 by 2 into 36. I mean, 1 into 36.
But I've got that's a bit of a dodgy situation because it's like you're just crossing something out because you think it works in this case. Does it always work? But we've got, for instance, I could do, like I said, that's times 10. So this also has to be times 10 is one way to look at it.
So we also just divide 2 by 20 because it's easy.
Yeah, you could do 2 divided by 20 as well, times 360. Depends if you've got a calculator, what you're doing. But there's lots of methods. So the way they're looking for it is 2 out of 20. This would be 1 out of 20. This would be 3 out of 20 times 360 degrees. Again, 2 out of 20 times 360, and so on. However you want to do it. Okay. Same thing here. This one would be 3 out of 20 is the same thing as something out of 360 degrees.
Yeah.
How would you figure that out? If you were going to do it in that way? Ian?
Well, if you multiplied, you have to do 360 divided by 20, which would make 18. That means 20 times 18 would make 360. That means 3 times 18 would make.
Okay, so if we worked out the 360 divided by 20 makes the 18 again. Yeah, that's one way. Sushi?
We could also do 3 by 20 in this way, like we could find out the LCM between 3 and 20, and then
The lowest common multiple of 3 and 20,
yeah, that's 60. Okay.
and then do what? So that becomes what?
So
60. What do you do with the 60? Because I want to find this.
So then with the 60 you can make it easier to divide. So now we can get.
So you would change it to
So
9/60.
Yeah, and then we can simplify it. No, wait, 360, then
Well,
that
actually,
get
60, if I then times this by 6, I actually get
360.
360 over
54.
54.
So it doesn't work.
Okay, that would give me, the question mark is 54. So, yeah, by doing equivalent fractions, we can get there as well. So, but the big thing is when we're doing a pie chart is that use of fractions, maintaining that constant fraction. So, basically, if I change the number of people in my survey now, what would it change to these calculations? Which number? If I were to change the number of people, what would it change?
Number 20.
The 20. It would change all of these. Okay? So whatever that number was here, that would be changed. Alright? The 360 never changes because it's the amount of degrees in a circle, and you never change that. Does that answer your question about how to find the angles, or is there other questions about the pie chart stuff?
Is there any quicker way to do it, or do we have to do that whole table for every single time?
Well, no, that's the calculation that needs to be done. It's the only thing I will say it's a bit different. So not quicker. I'm not answering your is it going to be quicker, because I think that's it really. I could do it in a different way, okay, and I could tell you the angle for an angle and number of people in one sector, and ask you to find the total number. So, for instance, let's say we've got a pie chart, and we have sections like this, and I tell you that this is 30 degrees, and it's people that like cake, and there are 27 people like cake, and then I tell you this one is 120 degrees, okay, that like crisps, and I say how many people like crisps. So I could give it you in a slightly different way. Louis, would you like to have a go? What would you do?
But 27 times 4.
27 times 4. Okay, yeah. There is the link between 30 and 120 is it's 4 times as big, yeah. So this would be 20 times 4. 27 times 4, yeah. That's one way to do it. Okay. There are other ways.
Could you do 360 divided by 30 and then find the amount of one person and then times it by 120?
360 divided by 30 is
112.
okay. So what does that tell me?
And then it tells you that one person is 12 degrees.
It doesn't though, does it? Because you're telling me that 30 people, but I don't know 30 people.
So no,
It's not this time, is it? It's what, Sushi?
It's 27 divided by 30. Or is it the other way around?
So it's 30 divided by 27 people. Okay? So that's the fraction now, and that will be the same as 360 divided by something. It will also be the same thing as 120 divided by something, right? Or I can do it the other way up, it's fine. So 27 in 30 degrees is the same as so many out of 360 is the same as something else out of 120 degrees, no? So what Louis did was say 30 times 4 gives me what? 108.
120.
30 multiplied by
80
4.
and 28 is 108. Yeah? No, you're right. That's what I wanted. Okay. 27 times. What is this one then? So 30 goes in times.
Or maybe
12,
120 goes in
so
times
it-
3. 120 goes in times 3.
260.
We can do it like that.
216.
216.
16.
No.
That doesn't look right.
Oh no, yeah, my bad. No, my bad. Times 3. It's 300, yeah.
No, it would end with a 4.
27
Yeah,
times 12. 2 times 7 is 42. So 4, 5, 54. Put a 0. 2 and 7. So it's 4. 324.
Yeah.
Okay. So there, I've answered the question, which is how many people in total would be 324 people in total. So again, but seeing the fractions, using the fractions, whichever way round you want to put them. So this way round or the other way round works absolutely fine. But you must remember to think, have I given you the total number of people or do I give you the bit of one section? Either way you can work it out. But setting them out as fractions really works quite well. Okay? We okay with that?
Yeah.
Okay. So